Okay, so traditional decomp, guys. I'm going to show you traditional decomp, and then I'm going to show you the method we learned last day. Okay? So traditional decomposition, you can hardly read that. It says traditional decomp. I'll pull it down. For the first one there, the product is different because now we have, it's not just the 6, okay, the last term, because now we have something in the front. And so that's actually affecting our whole trinomial. And so our product is going to actually be the product of the first and last, 2 times 6. Okay? So we want a product of 2 numbers that multiply to 12, and we're going to have a sum of still the middle term, 7. Okay? So we need to find 2 numbers that product to 12, and they add to sum to 7. What are the 2 numbers? 3 and 4. So in traditional decomp, we take those 2 numbers, and what do we do? Does anyone remember? We're uncollecting like terms. We're going backwards of FOIL. So we're going to take that middle term and we're going to split it up into the 2 that we collected before. So we wrote this as 2x squared plus 3x plus 4x plus 6. Okay, we uncollected the terms, right? If we're thinking of what we did when we FOILed, we're going backwards. Now, whenever we had 4 terms, what did we do? Split it into 2's, yeah. So we grouped the first 2, we grouped the second 2, and we pulled out common factor. So what's the common factor for the first 2? X, and what's the common factor for the second 2? Just 2, right? So what? I'm going to factor out that x, and so put it in front of the brackets. And then, so divide each term by x, and what's left over inside? 2x plus 3. And we factor out the 2. We don't just write 2, we write plus 2. Thank you. Plus 2. And we factored out of just those 2, and we left, if we did it correctly, and if the stars align, it should be the exact same thing that's in the first brackets, which is 2x plus 3. Now, what was our next step after this? We have a common factor of 2x plus 3, so we pull out the binomial that's a GCF, and we're left with x plus 2. Okay? This is the only example I'll do of this method because it's a lot of writing, right? A lot of writing, very easy to make a mistake. It's a lot faster to use the other method. And so we're going to, it's nice because it's not much different. I will not ask you, I will just say factor, and you use whatever method you're more comfortable with. Okay? So this method is called the Chinese method. And I'm telling you, I don't really like the name of the method, but if you need to find it on the website, online, like that's what it is called. Okay? It was actually, we had a student teacher, and she came in and years ago, she's like, this is way easier. And everyone's like, yeah, it is way easier. So ever since then, we use this. Okay, so what do we do? So it's the same process, right? We need 2 numbers that multiply to 5. So what are 2 numbers that multiply to 5? Multiply to 5. Product of 5. There's only one way. 1 and 5, or 5 and 1. No, that doesn't multiply to 5. Okay, and we're always looking for integers, so you're not gonna have decimals there. Okay, 5 and 1. Now, two numbers that product to 2. 1 and 2, or 2 and 1. So here is the issue, okay? So this is still going to be the sum of our diagonals. Sum of, can you read that? No, darn it. I need to change my, okay, so the 7x in the trinomial, 5x squared plus 7x plus 2. The 7 here is the sum of the diagonal products. Okay, the diagonal product. So what I mean by that, if I say, let's say I went 1 and 2, okay? Don't write this down, just watch. Do the diagonals add to 7 when we product them? 5 times 2? 10. 1 times 1? 1. So no, that didn't work. So a little bit of guess and check. Then what we need to do instead of going 1 and 2, we need to do 2 and 1. Oh. The big difference. Okay, I'm lost. Sorry guys. There you go. I lost myself here. Because it's going to change like what the factors are, right? So instead, we're going to use 2 and 1. Now, 1 times 5, does that product? Yes. 1 times 2, does that add to 7 now when we add those two diagonals together? The product of the diagonals. Yeah. And so, what is the factored form then? 5x plus 2 and x plus 1. Remember, we can go back and put in our variables. We actually want a product here, 5x squared. So this was 5x and 1x, right? And the signs here were positive. So 5x plus 2 and x plus 1. And there it is. Okay? Not much different than last day? Not really, right? We just had 1 and 1 before. But now we have a number in front. So notice if I put the 1 and 2 in a different order, it would have been 5x plus 1 times x plus 2. Which is, when you expand it, the middle term would have been 11x. And we wanted 7x. Okay, let's try another one. Okay? So, now, 6. How many ways can we multiply to 6? Well, we can do 3 times 2 and 1 times 6. So there's a little guess and check here. How about negative 3? Well, just 1 and 3, right? Now, if it multiplies to a negative 3, what do we know about our numbers? 1's negative, 1's positive, right? So it actually could be 1 and negative 3 or negative 1 and positive 3. Okay, so it's a little guess and check. We know our numbers are going to be, but we want our diagonals to sum to 17. So let's try, what do you want to try for the 6? What two numbers? 3 and 2? Sure. Let's try 3 and 2. And let's try what? We're going to do our signs last. So product of 3. 1 and 3 or 3 and 1? I heard different things. So, okay, 1 and 3. Let's try it. So we're going to try. Will this make can we make, if one of the signs is negative, can we make 17 out of 9 and 2? No. Okay, so let's try switching it up. So instead, this is where eraser comes in handy. Let's try 3 and 1. Okay, 3 times 1 is 3. 3 times 2 is 6. Is there any way to make 17 if we switch signs and stuff? No. So where does the change have to occur? The left side has to actually be 6 and 1. Okay, 6 times 1, 6. 1 times 3. Can we make 17 out of that? No, of course it's the last option that we try. It has to be 1 and 3. Okay, let's try now. 6 times 3 is 18. 1 times 1, 1. Now we want to sum to a positive 17, product of negative 3. Now we can throw in our signs. Which one is positive? We want the 18 to be positive, meaning the 3 is positive. And we need the 1 to be negative, meaning the 1 is negative. So what's our factored form going to look like? I can zoom in if it's helpful. Okay, 6x minus 1. You could throw in your variables now if you want, x and x, to make the 6x squared. And then x plus 3. That. Feel a lot like last day? Hopefully. Hopefully it's not a big jump. I find the first day the hardest, right? Because you're just getting used to this new method, and now it's just not much different. Yeah. We still have to check for GCF. A and B, like the one we just did, was there a GCF? No. How about B? No. Okay. There is no, so we're just going straight to factoring. There's no greatest common factor. We can't divide everything by a common factor. Okay? 3, we're going to have to do. What two numbers? 1 and 3. Good. Now 8, we have a few options. Right? 1 times 4. Nope. I'm still on vacation, maybe. I don't know. 1 times 8 and 2 times 4. Okie dokie. I'm trying to make a smaller middle, right? So let's choose numbers that are smaller. Let's do 2 and 4. Right? Notice how it was like 1 and 6. We're trying to make it big. So let's use 2 and 4. Okay, we want a sum of -2. So let's see if this will work. 1 times 4 is 4. 3 times 2 is 6. Can I make -2 out of that? How can I make -2? If we had a -6 and a +4, right? That would add to -2. So the negative had to be with the 2 and the positive with the 4, right? Would that work? 1 times +4 is 4. 3 times -2 is -6. So what is the factored form? 3n plus 4 and -2. So you could throw in your variables if it's helpful to you, or you can go straight to factored form. Right? And remember, each row is the factored, each binomial. Each row is a binomial. Are you ready to try the next one on your own? Why not? Because you're lazy. At least you're honest too, though. You're real with yourself. It's good. So, factoring out the GCF, what's the GCF? 5. So we're left with 3k squared plus k minus 2. We divide each one by 5 to figure out what's left over on the inside. Now we're good to factor. Okay, it's a type 2 because there's 3 and 1 and 2 and 1. Yeah, our options are very limited, but it could be 1 or 2, 1 and 2 or 2 and 1. So you said 2 and 1? Okay, so let's check that. 3 times 1, 3. 1 times 2, 2. Is there a way to make this a +1? Who has to be negative? 2 has to be the -1. 3 has to be the +1. So negative, positive. 3 times 1, 1 times -2. That would sum to 1. Okay, so when we write the factored form, right, here's our k and k. What do we have to remember? 5, okay? I can't tell you how many students forget to GCF on their tests. It's like, you teach them the harder stuff and they forget the easy, right? Don't forget to GCF if you can. Easy. Easy. I'm going to show you something in a second. So the final answer would be what? 5 times? Beautiful. Could you check your work on your calculator? Yeah? Yes, you can. The test feature, right? No? Okay, I want to show you something, guys. If you forgot to GCF, let's say you forgot to GCF, okay? If you did forget to GCF, you could still factor it. So you could do like 6 and, oh, not 6. Let's try this again. 15 and 1, okay? 15 and 1, and let's say you did 10 and 1, okay? And then you're like, okay, I need to make 5, and so you're like, oh, this is 15, this is 10, so it has to be a -10, +15, and so it factors to 15x minus 10 and x plus 1. That's true, but it's not fully factored. So if you forget to GCF, you're kind of lucky because you can just always also GCF at the end as well. Notice here, is there a GCF in this guy? A common factor. Yeah, it has a common factor of 5. So if you do forget to GCF in the beginning, make sure to check your factors because they might have a GCF. So I can factor the 5 out of that, and I'm left with 3x minus 2. Is that not the same thing? Oh, actually, it's a k, but whatever. Okay, but you get the idea. So if you forget the GCF, it's still probably going to be factorable, but it's going to have that GCF inside one of the factors. So you're welcome to, if you didn't see it, it might be obvious to you in your factors. Just pull it out then, okay? Because you wouldn't get full marks if you wrote your answer like this, even though that's true, and your calculator will tell you if you tested it's true, you're not going to get full marks because there's a GCF hidden inside one of the factors. Okay? All righty. Are you ready to try this one on your own? No?
Yes.
It's A. Oh, sorry. That's so mean of me. Number 6A. Do you want to try 5B on your own or no? Let's do 6A. Yeah. Oh, good. Yeah. Okay, let's do, and then we're going to be done. Short, easy lesson today.
That's it.
Yeah, that's it.
Easy.
Easy. Okay. Oops, that's... Hey, Marcus, do this question, please. Thank you. We're doing 5